Hi everyone, this is Surya. Currently, I am a PhD student at IIT Kanpur. Today, we will start a new chapter called Current Electricity Previous Year's Questions. So, going into the first question. So, here in question, there is a diagram. This is a potentiometer circuit setup as shown in the figure. Okay, this is a potentiometer as shown in the figure. It has potentiometer usually potentiometer is used for usually for finding the resistance and the ammeter present in the circuit. The potential gradient across the potentiometer is given as k volt per centimeter. Ammeter present in the circuit is reads 1 ampere when the two-way key switched off as shown in the figure. There is a two-way key 1 and 2 and 1 and 3. So the balance points where key between terminals 1 and 2 and 1 and 3 is plugged in are found to be L1 and L2 respectively. The magnitude of the resistors are given as R and X. There are two resistors, so those magnitudes are given in R and X in ohms. So they are asking the R and X in terms of K and L1 and L2. Okay, so let's see. So what is the how to solve this one? So potentiometer. So what is potentiometer here? It is shown as, you see here, potentiometer is usually it is a potentiometer. Okay, AB potentiometer here. So a long uniform AB is connected to a stable power source. So as shown in the figure, a long potential AB is connected to a stable power source. This wire has a constant potential gradient. This wire has a constant potential gradient. Okay, this wire has a constant potential gradient. So, and it is denoted by K. The potential gradient is denoted by K. So its unit is voltage per unit length along the wire. Okay, so unit is voltage per unit length along the wire. So, and there is a galvanometer. So it is a, what is galvanometer here? Galvanometer usually detects the current. Okay, galvanometer G is there here. So it is a sensitive device to detect current. It is used to detect the current. Connected through a two-way key here. It is connected through a two-way key. Okay, so what are the position? The two-way key, there are two-way keys, right? Two-way keys. So they are, this key allows to switch between two positions. Okay, so if we connect 1 and 2, there is a current flow in a different direction. 1 and 3, the flow is in different directions. So position 1 and 2, so it will connect resistor R only. So there is a position here as shown in the figure. Position 1 and 2 is there. It connects only the resistor R only. Okay, resistor R alone. So it's connected only if you two-way key as 1 and 2, then it connects only resistor R. If you use position 1 and 3, so it connects both resistors R and X. So it connects both the resistors R and X, right? So here the resistor R and X are resistance, the values we want to determine. So as in the question, they determined R and X in terms of K and L. So as shown in the figure, what is the potential gradient given? What is the potential gradient? potential gradient, what it means? Actually, I am telling the definition of potential gradient. Okay, potential gradient they given as K here. Sorry, K. The potential gradient is the rate at which the voltage drop across the potential wire. Right? There is a wire potential wire. The rate at which the voltage drops. Suppose voltage is V. Okay, so length is L centimeter. So V per centimeter. It is the volts per centimeter. It will tell us the potential gradient K. So then V is equal to, we can write it as, that means that along the length of the wire, V is equal to, we can write it as K into L, right? This is the thing of about the potential gradient. Now we will see. So what is the working principle here? When two-way key is plugged in two different positions, there are two positions, right? 1 and 2 and 1 and 3. The balance point on the potential wire, where the galvanometer shows us, there is a balance point on the potential wire, where the galvanometer shows the current passing through it. Okay, so here they told the current passing through it is 1 ampere, right? So there is a two-way key in two different positions as shown in the figure. The balance point of potential wire where the galvanometer shows the zero current changes. This balance point provides the specific length L on the potentiometer, which allows the calculate the voltage drop across R or R plus X, depend upon the which key you are using. So since the circuit is here, a circuit is designed, since here the circuit is designed for a current I equal to only 1 ampere, right? So this, they told that circuit is designed for I equal to 1 ampere. So flows through the resistors. So we can use Ohm's law. You know, V equal to I into R, right? This is the Ohm's law we can use. Voltage drop across, R is the resistance, the current flow, I is the current flowing. So we can use this formula to find the R and X in terms of K and L. So we know the relation between V and K already. V equal to KL ratio. So we will see now for in 1-2 position. So case 1 in is in it is in key in position 1-2, right? So there are position two-way keys 1-2 and 1-3. So it is only across R only, right? If the key position is 1 and 2, there is only resistance R. Already we discussed it before. When key is in position 1 and 2, only R resistor is connected. So now the galvanometer shows the deflection at some length. We will take it as L1 centimeter. So galvanometer shows the deflection at some length L1 along the potentiometer. So the potential difference across R matches the potential drop across L1. Then we can write across R is equal to I into R. What is VR? Now the potential gradient. So this is the Ohm's law we used. But what is the potential? I is the 1 ampere. So 1 here. So VR equal to R. So now what is we already know so you know the relation between V and K and L, right? Here VR is nothing but potential drop across length R1 is K into L1. Now R is equal to K into L1. This is the only. So from this we got this relation. So now the key, suppose case 2 in key position, case 2 is key position is in position 1-3. So now there is resistance R and X are both are connected in a series as shown in the figure. If 1-3 position is there, then across R plus X, R and X are in both resistors R. Both resistors as shown in the figure. Both resistors R and X are connected in series. Now they are connected in series. So when there is a connected in series resistance, what is the total resistance across that? It will be R plus X, right? And two resistance are connected, R and X in a series. The total resistance will be R plus X effective resistance. So here the galvanometer shows a different length. The galvanometer shows a different length L2, meaning the potential difference across V R plus X will be I into R. Here also I is equal to 1 ampere, it will follow. So VR plus X is 1 plus X. So using potential gradient, there is another formula for potential gradient, right? It is showing galvanometer showing the L2 length, right? So VR plus X is equal to, we can write is K into L2. So R plus X is K into L2. So before that we got equation R equal to K into L1. Now R is K equal to L1 and X is equal to K into L2 minus R. R is nothing but K into L1. So K into L2 minus L1 will be the X. X is equal to K into L2 minus L1. So we got R and X in the K and K. So what is the answer here? They are asking R and X. X is equal to, so option B is the right answer. So going to the next question, second question. In second question, there are three resistance are there. In second question, there are three resistance P, Q, R, each of 2 ohms. An unknown resistance. So these are the unknown resistance. The unknown resistance S form the forearm of a Wheatstone bridge. Okay. So what is Wheatstone bridge? We will discuss detailing. Then we will go. When a resistance 6 ohm is connected parallel to S, then so there is a 6 ohm resistance parallel to S, then the bridge get balanced. So then now the bridge get balanced, then what is the value of S they are asking? What is the value of S now? So before going to, so we will, so what is the Wheatstone bridge? We will see. First we will discuss about the what is Wheatstone bridge. Okay, so then we will go. So Wheatstone bridge is an arrangement. Okay, Wheatstone bridge is an arrangement of 4 resistance which can be used to measure one of the terms of the rest. So Wheatstone is used to measure the resistance. Okay, so Wheatstone bridge I will show you what is basically Wheatstone bridge, then we will go to the question. So there are different resistance. Okay, there will be galvanometer G, C. So across point A and B, this is the point A, this is the point B, where point B, there is a potential difference across. So this resistance is R1, this is R2, this is R3, and this is R4. Okay, so now the current is now following up. So there is a I1 going here, there will be I2 going here. So I is equal to I1 plus I2. So 4 of the resistors R1, R2, R3 are connected to form a loop here. Okay, there are 4 joints A, B, C, D, and there is a different here. There is a joint C and D. So there is a possibility current going in like this also, na, in CD direction. So if it is a Wheatstone bridge, okay, then what will happen? If R1 by R3 is equal to R2 by R4, then what will happen? So then there will be a potential. So there is a potential, equal potential drop. VA minus VC is equal to VA minus VD will happen. So there is a equal potential. Potential at C is equal to potential at D. So there will be a no flow of current along CD. So then what will happen? The galvanometer shows 0, right? There is no measurement of current there, right? So then the Wheatstone bridge is said to be balanced when there is a no current through a galvanometer. So okay, this is the Wheatstone bridge speciality. So by using this we can find the resistance without measuring the resistance. There is no current across the galvanometer. Potential difference across terminals will be zero. Okay. So here you can see, if VC equal to VD, then what will happen? If VC equal to VD, applying Ohm's law, VA minus VC will be I1 R1. Okay, the potential difference current flowing, and VC minus VB is equal to I2 R2. If we divide VA minus VC by VC minus VB is equal to R1 by R2, right? Similarly, applying for R3, VA minus VD is I2 R3. VD minus VB will be I2 R4. So VA minus VD by VD minus VB is equal to R3 by R4. So you know VC, here VC is there, and VD is the both are equal. Then what will happen? Both R1 by R2 is equal to R3 by R4. So this is the condition when Wheatstone bridge is balanced. So now here in the question, what they had given, they said three resistance PQR of each unknown form a four arm PQR each of, like there are 4 arm bridge, right? Sorry, there is a 4 arm bridge. Okay, there is a PQR each of 2 ohms, and unknown resistance S form a 4 arm bridge. We don't know this unknown resistance. You know PQR 4 arm bridge. Now we don't know it is balanced or not. Okay, still it is not a it is still a Wheatstone bridge, but we don't know it is balanced or not. Okay, so there is a galvanometer here to measure. So what they are saying that if I add a 6, if I add a 6 ohms of resistance parallel to S, then it will get balanced, they are saying. So what will happen now? For to balance, we know the for Wheatstone bridge, na. So what is the concept of Wheatstone bridge? So here we will take it as S equivalent. We don't know, suppose. So you know, if 2 are in parallel circuit, suppose 2 R1 and R2, suppose in parallel circuits, what is the formula? Resultant resistance formula? 1 by R is effective is equal to 1 by R1 plus 1 by R2, right? So R effective equal to R1 R2 by R1 plus R2. So here it is S and 6 are in parallel. So S effective will be, so this I am taking as S effective, right? S effective will be 6S plus S plus 6. So now there is, so now my diagram is very bad, so I will draw it again. Okay, now there is a, this is the S effective now. Okay, this is PQR. Now it will form the Wheatstone bridge if we S effective. So what is the formula for Wheatstone bridge? P by Q is equal to R by S effective, right? So P and Q are equal. 2 ohm divided by 2 ohm. R is 2 ohm divided by 6S divided by S plus 6, right? Now what will we do? So there is a, 2 ohm, 2 ohm will cancel. 6s divided by s plus 6 is equal to 2 ohms. So now it is 6s plus 2s plus 12, right? So 4s is equal to 12. Then s equal to, we can write it as 3 ohm. So s equal to 3 ohm here. Okay. So this is the concept of V-stone bridge. This is how we apply this here. So next question. So next question, in a given circuit, what they are, in a given circuit, a conductor wire connected between points A and B. So here there is a circuit. Okay. Point A here, it is a point B. A given circuit. So this is a given circuit. A conductor, there is 4 ohms. This is 1 ohm, 3 ohms, and 4 ohm, right? So what is happening here? It is connected between points A and B. Current in this wire, suppose it is current, there is a connecting wire between point A and B. So what will happen? Current in which, so in flow in which direction will be happen? A to B, B to A, there will be no current. So let's see, it is a Wheatstone or bridge or not. 4 by 1 and 4 by 3 both are not equal. So if it's a 4 by 1 is not equal to 4 by 3, so definitely it is not a balanced Wheatstone bridge. So definitely the potential of VA is not equal to VB. So there will be definitely, there will be current flow, but we have to see where it will go from A to B or B to A. How we will know? So so carefully we can say that, like, every time the current will flow from higher potential to lower potential. So we have to know either VA greater than VB or VA less than VB. Then we will get to know the direction of potential. So there will be a potential difference between these two, right? We will take it as V. The potential difference here, there is a potential difference here. So what will happen now? There is a so there will be a 4 ohm resistance and 1 ohm resistance, right? So suppose if I take a current I, it will go I1 here, some I1, it will go I2 here, right? So the potential difference across these 2 points is V, suppose. So V is equal to, so here V, it is VA, V minus VA. Here the potential is, suppose I will take as point C and point D, okay? VC minus VA is equal to 4 into I1, right? VC minus VB is equal to 1 into I2, right? So we want to know the sign between these two, right? How we will know the which potential is higher? So VC minus O. If you take these two difference, minus VA plus VB is equal to 4I1 minus I2. So still we don't know the, so I1, I2 we don't know, na? So I1, I2, how we will get the ratio of current division? So you know the resistance in which, so here there is a, see, you can see these two are in series, 4, 4, 4, right? Here these two are in series, 3. So totally it is 8 ohm resistance, and here it is 4 ohm resistance, right? So when there is equal potential difference, so there will be current which is dividing, suppose in which area resistance is less, 4 ohms, so more current will go there. Here less current will go there. So in what ratio it will go? V is equal to IR, right? I into R. When there is equal potential difference, I1 R1 is equal to I2 R2. Here 8. So I1, I will take it as I1. Here I2, I will take it as. So I1 into 8 is equal to I2 into 4. So I2 will be 4I1, right? I2 will be 4I1. So definitely I2 will be 4I1, right? So here the resistance is less. Here resistance is less. The potential, here the resistance is more. The current flow will be low. So what will happen? The potential at A is less compared to B. Hence the potential current will flow from B to A. Why? Did you understand this one? Now going to the next question. From the network here, the value of current I. So from the value of here, we have to know the current I. How will get to know? So there is a 4 ohms, there is a 2 ohm, there is a 6 ohm, there is a 4 ohm, there is 2 ohm, there is a 4 ohm again, there is a 3 ohm. So then the ratio, here you can see 4 by 6 is equal to 2 by 3. There is a balanced Wheatstone bridge. So then there is no current flowing in a 4 ohm direction. So there is no use of this thing in between. Well, this is a balanced bridge. So there is a 4 ohm and there will be 2 ohm and 6 ohm. There will be 3 ohm. There will be current I. So here the total resistance will be 6 ohm. Series, they are in series. Here the total resistance will be 6 into 3 by 6 plus 3. It will be 27. 3 6 are 18. Sorry. Divided by 9. It will be 2 ohms. Both are in parallel now, right? Current flowing I. So it is the voltage V. So what is the next thing? 6 into 2 by, oh, here 6 and 3, it is 9, right? Then what will happen? 6 into 9 by 6 plus 9. This is the R effective totally. So 6 into 9 will be 9 6 are 54. 6 plus 9 will be 15. So there will be 3 cancelling out. How many times? 1 times 18. 24 8. So 3 will be 5. So 18 by 5 ohms are effective. So now what is the current I equal to? V by R. So V equal to 18 by 5. It will be 5V by 18. Option D is the right answer. Current will be. So next question. There are equal, here there are equal 5 equal resistance are connected as shown in the figure. A battery V volts is connected through A and B. The current in AF CEB. Okay, we will see this thing. There is a initially. Okay, we will start from A to B, right? There is a. So we will see A is connected to F, right? Then F is, there are two resistors from F. It is C. It is another thing is D, right? A to F, there is a C. From F to there is a C and there is a D. From D to, then C to E, there is a R. C to E, again there is a R. Okay, from C to E. The C to D, there is another resistance. C to D, there is another resistance. C to D, there is another resistance R. Okay, from again E to E is connected to B. E is connected to B, some B. And E and D are connected to see E and D. Let's E and D are connected to R. So this is the diagram. So we are asking what is the potential current flowing AF CEB. So in upper part, what is the current flowing? So we will see everything is R, 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 R. So here there is a FCED, Wheatstone bridge. So R by R is equal to R by R. So Wheatstone bridge. So there is a no current flowing in CD. So we can remove it. So we can remove it. AF, there is 2, R, again R, point C. This is E, it is connecting to B. Similarly, F, D, again there is R, and V. So what is the effective resistance here? It is 2R. 2R is the effective resistance. Here also it is 2R. So now resultant effective resistance, what is the resultant effective resistance? So it will be R effective will be, if 2R in parallel, this 2R in parallel. So 2R into 2R plus 2R plus 2R. So it will be 4R square by 4R. So resultant is the R. R effective will be the R. So total current I is equal to V by R. But they are asking there is a I is divided into I1 and I2, right? So in both directions the resistance are equal. So it is current divided equally. So I1 is equal to I2. Both will divide because in both directions resistance are equal. So I1 plus I2 will be V by R. I1 equal to I2. So 2I1 is equal to V by R. So I1 is equal to V by 2R. So the current flowing through the AFCEB will be V by 2R. Next question. Total current in a circuit will be V by R. So in Wheatstone bridge, they are saying in Wheatstone bridge, in a Wheatstone bridge, all four arms have equal resistance R if the resistance of galvanometer in a Wheatstone bridge, all four arms have equal resistance R. If the resistance of galvanometer is also R, then the equivalent resistance of combination of a battery they are asking. So if Wheatstone bridge is balanced, so you know Wheatstone bridge, right? So there is a R. There will be a point here, point A. There is another resistance here, another resistance. Okay, R. So Wheatstone bridge is balanced. CD, AB. So here it is R, galvanometer of resistance R. So if it is a balanced Wheatstone bridge, so R. So R will be there. So C and D. So when Wheatstone bridge is balanced, there is no current flowing. So it will be ineffective. R will be. So okay. So now there is ineffective resistance R in between. So the equal resistance of the combination will be, there will be R here and R here. Here. There will be R. So both are in series. There will be 2R. Okay. So net resistance will be 2R. Both are in series. So again it will be 2R. So if both are in parallel, then R effective will be 2R into 2R plus R plus R. 2R plus 2R, sorry. So you know R effective and the 2R in series will be, if both are different, R1 R2 by R1 plus R2. We applied the same formula. So it will become again 4R square by 4R. It will be R. So Wheatstone bridge is most sensitive in all arms bridge have equal distance. So option D. Seventh question. If a specific resistance of a potentiometer wire, is given as 10 power minus 7, then the current flow is 0.1 A ampere and the cross sectional area is given as 10 power minus 6 meter square, then the potential gradient will be. So you know the potential gradient V is equal to I into R. They had given I is equal to 0.1 ampere. So we have to find out the R from the specific resistance. So you know R is equal to rho L by A. Right? What is rho? It is the specific resistance given as 10 power minus 7 ohm meter. Length is L. Okay. Then what is area? It is 10 power minus 6. So it will be 0.1 L. R is 0.1 L. So V is equal to, already it is a 0.1 ampere and R is 0.1 into L. So it will be 10 power minus 2 L volt per meter. Volt. So here already there is a L. So we want the potential gradient. V by L will be the potential gradient. It will be 10 power minus 2 volt per meter. So option A is the right answer. Eighth question. The potentiometer measures the potential more accurately because. So why the potentiometer more accurately than voltmeter? Primarily because it does not draw the current from the circuit being measured. Draw current from circuit being measured. So but like voltmeters will draw the current, but here potentiometer won't draw that current from the circuit being measurement. Okay, zero current measurement. The potential more accurately because it measures potential in open circuit. So it will measure in open circuit, hence the error in potential due to internal resistance is removed. So the internal resistance also can be removed. Okay, so that's why. So option A is the right answer. It measures the potential in open circuit. So next question, ninth one. 5 resistors have been connected as shown in the figure. The effective resistance between A and B. So here A, there is 3 ohm, 4 ohm, 6 ohm, 8 ohm, there is 7 ohm, B, A. The 3 ohm, 6 ohm, 4 ohm, 8 ohm and 7 ohm. So the effective resistance between A and B is, here you can see there is a Wheatstone bridge which is balanced. So 3 by 6 is equal to 4 by 8. Half equal to half. So the 7 ohm. So there is no potential difference between these 2 points C and D. Suppose if we are taking C and D, so it is ineffective. This resistance will be ineffective. So now we can take it as 3 ohm, 4 ohm are in series, and again 6 ohm, and 8 ohm are in series, A and B. So 3 and 4 ohm is they are in series, so total it is 7 ohm and it is 14 ohm. It is B. It is A. So now the total effective is, if two resistance are in parallel, is R1 R2 by R1 plus R2. So here it is R1 is 7, R2 is 14. 7 into 14 divided by 7 plus 14. So it will be 21. 7 into 14 will be 21. So it is 7 into 14. It is 7 into 3. 7 7 cancel. So 14 by 3 is the resultant resistance. So next question, 10th question. A 6-volt battery. A 6-volt battery. There is a 6-volt battery connected to a terminals of 3 meter. Okay, a 6-volt battery connected through a 3 meter wire, long wire of uniform thickness, resistance of 100 ohms. The resistance is 100 ohms, 3 meter. It is connected to a 6-volt battery. So the difference of potential between 2 points on wire separated by a 50 centimeters. So if you take any 50 centimeter of this thing of wire, so what is the potential difference across that? So you know R is proportional to, resistance is proportional to length L. So if it is a 3 meter, means it is 300 centimeter. The resistance is R is equal to 100 ohm. If it is a 50 centimeters, then resistance will be R dash. We will take R dash is equal to 100 divided by 300 into 50. So 50 centimeters and it's ohms. So it will be 650 by 3 ohms. So total current I into R will be how much it is? 6 volts. Right? Now we want the potential difference across that 50 centimeters. We don't know. It will be I into R dash. So you know R dash, I is 6 by R, right? Into R dash. So here I is 6 by R. You know R and R dash, right? 100 and 50 by 3. It will be 2 times. So 1 volt. So 50 centimeters length will have 1 volt. Next question. Option D is right answer. Here the resistivity resistivity is nothing but specific resistance here. Specific resistance of a copper wire so it is increase with increase in temperature, decrease with increase in temperature, increase with increase length, increase with increase cross section. They are asking. So basically the resistivity of copper wire is a so the resistivity of copper rho T is depend upon the temperature, like rho naught into alpha plus delta T. Like most metals, copper increases with temperature, so its resistivity increases with temperature. The relationship according to here, as the temperature increases, alpha is positive for copper metals. So moderate temperature changes, resistivity is increases with temperature. The explanation is that temperature rises, the atoms in the copper lattice. In the copper lattice, atoms will vibrate more intensely, so increasing scattering of electrons, therefore increasing resistivity. So if copper wire is heated, the resistivity will increase and it will conduct electricity less than efficiently at low temperature. So at low temperature, copper is less efficient for conduction of conduct electricity. So increase with increased temperature. The option A is right answer. So next question. Silicon Si and Cu copper are cooled. They are cooled at to a temperature of 300 Kelvin. Then the resistivity. So we already discussed, as the temperature increases, copper resistivity increases. As temperature decreases, copper resistivity decreases. So here it is they are cooling to 300. So temperature is decreasing. So definitely Cu will decrease. So option A and C might be right because B and D are wrong, because as temperature decreases, Cu increases. That's wrong. It increases both and Cu won't increase. Cu definitely will decrease. So option between option A and C we have to choose. So we'll come into the silicon. So what will happen to the silicon when silicon has a semiconductor behavior? Okay, it has a resistivity that decrease as temperature increases. So silicon resistivity will decrease as temperature increases, but here we are temperature decreasing. The silicon resistivity should increase. So definitely for silicon it increases as the decrease in temperature. For copper it decreases. So option A is the right answer. So next question. A wire has a resistance. A wire has a resistance of 3.0 ohm at 330 degrees centigrade and resistance 5.5 ohm, 4.5 ohm at 100 degrees centigrade. So the temperature coefficient of resistance, will be, so you know the resistance formula, R is equal to R naught into 1 plus alpha temperature. So alpha is in everything in a centigrade unit. Suppose alpha, they are asking the temperature coefficient of resistance alpha. So they said that it is at 3.1 when temperature is at 30, 1 plus 30 alpha. And they said it is a 4.5 and temperature is 100. So 1 plus 100 alpha. When you divide both, 3.1 divided by 4.5 is equal to 1 plus 30 alpha divided by 1 plus 100 alpha. So if you calculate 3.1 plus 310 alpha, 4.5 plus 3 into 45, 135 alpha. So 310 minus 135 alpha, 4.5 minus 3.1. 1.4 divided by 310 minus 135. So alpha we will get as, if you simplify this, 0.08 degrees per centigrade. So coefficient of resistance, temperature coefficient of resistance will be option A. So next question. The resistance of discharge tube. What is discharge tube? In discharge tube, the current is due to flow of positive ions or electrons. Moreover, secondary emission of electrons is also possible. So VI curve is non-linear and resistance is non-ohmic. So it is not ohmic, it is a non-ohmic. Option C. So there are 3 copper wires. There are 3 copper wires of length, cross-sectional area L, A. There is first wire, and second is 2L, A by 2. Area is A by 2. And third wire is L by 2 and area is doubled. So in which case the resistance will be minimum, they are asking. You know, this is the first case. Here the resistance I will take it as R1. Here R2. Here R3. Here R1, so they are asking the minimum of R1, R2, R3. So in first case, we know the resistance is rho L by A. So R1 will be rho L by A. R2 will be rho 2L by A by 2 is equal to 4 rho L by A. R3 will be rho L by 2 divided by 2A. So it will be rho L by 4A. So R3 is R1 by 4. R2 is 4R1. So R2 is the maximum one, R3 is the minimum one. So R3 less than R1 less than R2. So R3 means what we consider, which has a cross-sectional area 2A, which is the minimum. So option B is the right answer. So next question. If the resistance of a conductor is 5 ohm, if resistance of a conductor is 5 ohm at 50 degrees centigrade and 7 ohm at 100 degrees centigrade. Okay, 5 ohm at 50 degrees centigrade and 7 ohm at 100 degrees centigrade. The mean temperature coefficient of resistance of the material. They are asking the mean temperature. So they are given the 2 temperatures. T2 is greater than T1. Okay, we are asking at the mean temperature. So R is equal to R naught into 1 plus alpha T, right? It is the 5 ohm at 50 degrees centigrade. R naught into 1 plus 50 alpha. 7 ohm R naught into 100 plus alpha. So if you divide both, 5 by 7 is equal to 1 plus 50 alpha divided by 1 plus 100 alpha. So if you solve this and so here 5 plus 500 alpha, 7 plus 350 alpha. So 150 alpha is equal to 2. Alpha is equal to 2 by 150. 15 to 0.01, 15, 5, 0, 3, 45, 3. So this is the actually alpha, but they are asking at the mean temperature coefficient. So the mean temperature coefficient is not actually alpha. It is at the mean temperature. So we can find the mean temperature coefficient. So they are given at two different temperatures. So T2, there is a relation between RT1 into 1 plus alpha T2 minus T1. So this is the mean temperature coefficient now. So it is 7 into 1 plus 100 minus 50, it is 50. So now if you follow, alpha is equal to 7 minus 5 divided by 250. So it is 2 by 250. So it is alpha is equal to 0.008 per degree centigrade, right? So this is the mean temperature coefficient. Okay. So next question 17. If a negligible small amount of current is passing through a wire of 15 meters of resistance, wire of 15 meters and resistance they are given as 5 ohms. Uniform sectional area is cross section area 6 into 10 power minus 7 meter square. So they are asking the resistivity. So all of you know the resistivity formula. R is equal to rho L by A. Okay. So this is resistance. They know 5 ohm they had given. Rho is the resistivity. Length we know 15 meters. And the 6 into 10 power minus 7. So if you take rho is equal to 6 into 5 into 10 power minus 7 divided by 15 is equal to 2 into 10 power minus 7 ohm meter rho. So rho is the coefficient of resistivity. Okay. So we will stop here. From tomorrow we will start from 18th question. Okay. Thank you.